This is the early afternoon of the 29th of June, 2023. This is my 16th video for the day. Probably my last one for the day. But I need to get it out there. This plays for 18 minutes and 2 seconds. James Cameron just announced a terrifying new discovery in the Oceangate submarine. Images the vastness of the ocean, its depths shrouded in mystery. Within it embraces a tragic tale waiting to be uncovered. So let's sit back and have a listen.
We always understood that this was the wrong material for submersible hulls because with each pressure cycle, you can have progressive damage. Because you may have a number of successful dives, which is what happened here, and then have it fail later.
Imagine the vastness of the ocean, its depths shrouded in mystery. Within its embrace lies a tragic tale waiting to be uncovered. As hopes fade for the 5 wealthy Titanic tourists who vanished while exploring the wreck aboard a mini submarine, one question keeps arising. What happened? It is another mystery of the deep, a haunting enigma that has captivated the world's attention. Today, we embark on a journey to explore the secrets of the deep sea and unravel the harrowing events surrounding the ill-fated submersible, Titan.
I know what happened. What happened was that section of glass, the viewing port, it let go. It was never designed to go to the depth that it went to. Let's go back and listen.
What happens when a submersible, designed for deep-sea exploration, goes missing with its crew on board? Well, that's precisely what occurred on June 18, 2023. Titan, a remarkable vessel operated by Oceangate, vanished in the international waters of the North Atlantic Ocean near Newfoundland, Canada. Its mission? To gaze upon the haunting wreckage of the RMS Titanic. Tragically, all 5 individuals aboard, a British billionaire, one of Pakistan's richest men, his son, a famed French explorer, including Stockton Rush, the founder and CEO of Oceangate, were lost. What happened and the shortcuts that were taken made me furious. Today we will delve into the details, seeking answers and valuable lessons from this catastrophic event. Before we dive deeper into the specifics of this tragedy, let's first explore the history of Oceangate, the company behind the ill-fated Titan. Oceangate Incorporated, a privately held U.S. company based in Everett, Washington, specializes in providing submersibles for the tourism industry, research, and exploration. Founded in 2009 by Stockton Rush and Guillermo Solon, Oceangate was born out of Stockton's unfulfilled dream of becoming an astronaut. After working as a flight test engineer for the F-15 Eagle, he redirected his passion towards undersea exploration. Interestingly, Stockton's wife, Wendy Rush, is a descendant of Isidore and Ida Strauss, who tragically lost their lives in the sinking of the Titanic. This connection adds a haunting twist to the story we're about to uncover. To truly understand the magnitude of deep-sea exploration, we must appreciate the challenges involved. While aviation and space travel capture our imagination, venturing into the depths of the ocean presents even greater engineering obstacles. The key lies in one crucial factor: pressure. We often overlook air pressure since it's just 14.7 pounds per square inch at sea level. However, water, being a denser fluid, exerts much more pressure. With every 10 meters, 32.8 feet descended, the pressure increases by 1 atmosphere or 14.7 psi. The RMS Titanic rests on the ocean floor at a staggering depth of 12,500 feet, with its broken parts scattered over 2,600 feet. This immense pressure, coupled with the ship's remote location, 400 miles off the coast of Newfoundland, paints a vivid picture of the perilous conditions awaiting any deep-sea expedition. Can you imagine lying on your back with a 1 foot by 1 foot board? Now picture the weight you'd feel on that board as you dive deeper. At 100 meters, 328 feet, equivalent to the size of a soccer field, the weight on that small board would be a staggering 20,880 pounds, about 4.7 Tesla Model Ys. As we descend to 381 meters, 1,250 feet, the height of the Empire State Building, the pressure reaches 37.4 atmospheres. That same 1-foot board would bear a weight of 80,000 pounds, pressing down with incredible force. And at 828 meters, 2,717 feet, equivalent to the Burj Khalifa's height, the pressure surges to 82 atmospheres, resulting in a weight of 173,520 pounds on that seemingly insignificant board. The Oceangate Titan was designed to withstand a maximum depth of about 4,000 meters, a testament to the extraordinary engineering required for such a...
The problem was that it might have been, but the viewing port wasn't. It was designed for 1,300 meters, period. 4,250 feet. Let's go back.
Evers.
Ad popped up. I'll get rid of it.
Now, let's address the red flags that plagued Oceangate from the start. It's important to note that the design limitations of the Titan necessitated the hatch to be bolted from the outside with 17 to 18 bolts. This meant that the passengers inside had no means of opening the hatch themselves, relying solely on ground crews. While this is understandable for safety reasons, it highlights the need for backup systems, such as explosive detonation cords, to ensure the hatch can be opened in case of emergencies. Surprisingly, the Titan lacked GPS or navigational instruments, along with a locator beacon similar to an aircraft's black box.
I had said that was insane, that it never had that capability to be able to be located by itself. I mean, it's just insane. An ELT, that's all it needed, but it didn't have it. Let's go back.
Marines utilize GPS for near-surface navigation, but in deeper waters, dead reckoning becomes the primary method. In contrast, the Titan seemed to rely solely on data provided by the surface support vessel. These deficiencies, combined with other concerns, painted a worrying picture. To be frank, Oceangate's statements about their commitment to safety seemed dubious. Their claim that the vessel's certification focused solely on physical attributes, rather than cooperation with Oceangate in 2022, revealed that the surface support vessel lost track of the Titan for several hours, causing great anxiety among the passengers. The absence of a locator beacon, despite prior discussions, only added to the distress. Furthermore, controlling the craft with a video game controller might seem trendy and innovative, but when it comes to safety, military-grade products undergo rigorous testing to ensure reliability in all operating environments.
And it's all run with this game controller and these touch screens. So if you want to go forward, you press forward. If you want to go back, you go back. Turn left, turn right, go down, go up. And it's Bluetooth, so I can hand it to anybody. And it's meant for a 16-year-old to throw it around.
Oceangate's disregard for these critical factors is concerning, to say the least. Let's take a moment to explore how Oceangate arrived at the Titan. It began with their acquisition of Antipodes, a submersible, in 2012, serving as their initial testing platform. Cyclops 1, a deeper sea vessel developed in collaboration with the University of Washington's Applied Physics Laboratory, followed. With a maximum depth of 500 meters, it still fell short of the Titanic's resting place. Finally, the Titan emerged as Oceangate's ultimate creation, rated for a breathtaking depth of 4,000 meters. One noteworthy aspect is that the Titan boasted a carbon fiber and titanium hull, making it an exotic addition to the realm of materials engineering. Carbon fiber, although utilized in high-end applications such as supercars and select aircraft, remains relatively unexplored. Ensuring its integrity poses a significant challenge, both in design and manufacturing. Oceangate signed a contract with Spencer Composites in January 2017 for the carbon composite cylinder. This was the same company that built the Deep Flight Challenger, a remarkable single-person submersible that was designed to conquer the depths of the ocean. Built by a company that had previously constructed the composite pressure hull for Steve Fawcett's Challenger, this vessel caught the attention of Richard Branson's Virgin Oceanic. Branson's company had ambitious plans to conduct a series of dives to the deepest points of the ocean. However, the creators of Deep Flight Challenger refused to endorse the plan. Why did they hesitate to support such a prestigious endeavor? Well, It turns out the Deep Flight Challenger was designed to dive only once. The craft's strength decreased with each subsequent dive, making it unsuitable for multiple excursions. Adam Wright, the president of the firm, explained that their intention was to set a record dive to the deepest point and retire the submersible as an exhibit in the Smithsonian. This crucial engineering decision brought to light an important factor in the operational lifetime of such groundbreaking technology. Curious to learn more about this intriguing project, I visited Oceangate.com, only to find that their website had been taken down. The disappearance of the Titan, another submersible, raised further questions. The University of Washington denied any involvement in the design, engineering, or testing of the Titan. Boeing, too, clarified that they were not partners in its creation. Even NASA's involvement seemed less significant than it initially appeared. Although the agency had a Space Act agreement with Oceangate, it did not contribute to the testing and manufacturing processes. This revelation highlights a classic example of a company seeking credibility through partnerships, even though the extent of those partnerships remains unclear. The allure of affiliating with NASA can be compelling, but it's essential to understand the true nature of the collaboration. In this case, it seems that the partnerships were not as substantial as they appeared, leaving many questions unanswered. But the most concerning aspect of this story lies in the lapses in quality control and safety measures. David Lockridge, the Oceangate Director of Marine Operations, filed a quality control report in January 2018. He alleged that no non-destructive testing, NDT, or investigation of the carbon fiber hull had taken place. NDT is a critical method for assessing the safety of materials without causing damage. It allows engineers to detect potential flaws or weaknesses before they compromise the integrity of the structure. Carbon fiber, unlike other materials, doesn't exhibit visible signs of wear and tear. It doesn't bend, yield, or develop cracks easily, making NDT even more crucial. But Lockridge was informed that Oceangate would rely solely on a real-time acoustic monitoring system. He believed that this system wouldn't provide sufficient warning to the crew if a failure was imminent. Concerned about the crew's safety, he expressed his reservations during a meeting. To his surprise, Lockridge discovered that the acrylic window through which the crew looked was only rated for 1,300 meters.
That, my friend, is the key. And it amazes me that the United States Coast Guard is screwing around trying to figure out what happened. This is what happened. That viewing port let go. End of story. I showed you a video where they removed a section and they had a crane with a wrap going through the viewing ports. The glass was gone. That's why it failed. Let's go back.
Oceangate refused to fund the design of a window rated for the vessel's intended depth of 4,000 meters.
Now think about that. They refused to fund creating a viewport that would go down to 4,000 meters, yet they intended to go to 4,000 meters. Do you need to know any more? Huh?
Frustrated by the lack of attention to safety, Lockridge reiterated his concerns and refused to allow further testing without a proper inspection of the hull. As a result, he was dismissed from his position. Oceangate filed a lawsuit against Lockridge, accusing him of sharing proprietary trade secrets and fraudulently manufacturing a reason for dismissal. The lawsuit was settled in November 2018, but the details of the settlement remain sealed.
He was paid a lot of money to keep quiet so they could continue with this project.
In December 2018, during a human-piloted descent, the Titan experienced communication problems due to interference caused by vertical thrusters used to overcome unexpected positive buoyancy. This resulted in a 1-hour loss of contact. While the pilot, Rush, celebrated becoming the second person to solo dive to 13,000 feet, the communication failure raised significant concerns about the safety of future missions. Following these tests in January 2020, the Titan's hull exhibited signs of cyclical fatigue, leading to a derating of the craft to
It wasn't the hull. It was the window, the viewing ports. Let's go back.
1,000 meters. Although the hull was repaired and re-rated for 4,000 meters, questions remain about the adequacy of the repair process and the overall adherence to proper engineering practices. This story is particularly troubling because it highlights the lack of regulatory oversight in such endeavors. Unlike commercial aviation, which adheres to strict safety regulations, deep-sea exploration operates in international waters with minimal regulations. The safety measures that ensure our confidence in aviation, from the involvement of companies like Boeing and Airbus to the oversight of regulatory bodies like the FAA, are absent in these ventures. While ambition is admirable, the importance of safety and thorough engineering cannot be overstated. Every engineering device has an operational lifetime, and understanding its limits and adhering to proper protocols is paramount. Safety measures, quality control, and comprehensive inspections are vital to mitigating risks and preventing catastrophic failures. A person who went on the submarine said there were communication issues every time they went on their 4 separate dives.
When we went down, there were communication problems on every trip I've taken of the 4 separate dives.
Guy's an idiot to have gone down 4 times. The first time should have been enough for him. Complete idiot. He's lucky to be alive.
I've taken with Oceangate. Every time there was a problem with at least, sporadically communicating with the surface. And
now let's shift to the 5 major pieces of debris revealed the tragedy's story. The initial clue was a nose cone discovered by the U.S. Coast Guard's remote-operated vehicle. This finding was followed by a large debris field containing various components. The pieces matched the design specifications of the Titan, unveiling the violent manner in which the vessel had met its end. The debris bore witness to the vessel's implosion, crushed by the immense pressure at the depths of the ocean. To demonstrate this force, an experiment was conducted, subjecting a styrofoam coffee cup to the crushing pressure of the ocean floor. The visual representation was striking, showcasing the unfathomable power that can destroy even the most durable structures. With the catastrophic implosion came questions about the events leading to this tragedy. The Titan was an experimental submersible, and the company's CEO had a cavalier attitude towards safety, embracing innovation and untested materials. The consequences of these choices became evident. During the news conference, a crucial detail emerged: the timing of the implosion. The Titan had lost contact with its mothership, and a delay occurred before the Coast Guard was alerted. It was during this period that the implosion likely occurred, leaving no signs on the surface. Consider the crew's final moments, trapped in a carbon fiber vessel, isolated in darkness, limited supplies and dwindling oxygen reserves. The fear of a slow and unbearable death loomed large. However, in this tragedy, death would have been instantaneous, mercifully swift. You see, it was a marvel of engineering, constructed with a mesh weave of carbon fiber, an incredibly strong and impressive material. However, carbon fiber was relatively new, and not as well understood as traditional materials like steel and aluminum. The Titan represented a new frontier in deep-sea exploration, a vessel designed to withstand the immense pressures of the ocean's depths. It was the dawn of a potential era of commercial underwater exploration and the prospect of deep-sea tourism. New frontiers always bring with them a sense of excitement and glamour. Think of space tourism, where wealthy individuals could buy a ticket to tour the moon and enjoy a catered lunch. But with new frontiers, there are always unknowns. No playbook exists to guide us. The Titan aimed to push the boundaries of our understanding and capabilities. It successfully made several dives to the Mariana Trench, the deepest part of the ocean, and returned unscathed. However, on its 4th attempt, something went terribly wrong. During that fateful dive, the vessel experienced deformations and structural failures. It seemed that the Titan had reached its operational limits, and the risks it faced were too great. But why did this happen? Was the operational lifetime of the Titan ever established? Here's the thing. Exploring new frontiers requires continuous learning and improvement. The ocean's depths remain largely unexplored, with more unknowns than certainties. The vessel's creators, driven by a desire to make deep-sea exploration more accessible and affordable, took shortcuts and made assumptions. Perhaps the ticket prices, starting at $125, were too low to sustain proper vessel maintenance and replacement. To truly understand the depths and withstand the immense pressures, disruptive testing and periodic vessel replacements should have been considered. Sadly, tragedy struck, and lives were lost. As an optimist, I had hoped for a different outcome, a chance to learn from mistakes without sacrificing human life. But engineering teaches us that we must always learn from our mistakes, no matter how difficult or tragic they may be. If you believe in freedom and personal choice, you may argue that these explorers willingly took the risks. However, did they fully comprehend the nature of the vessel and the true extent of the risks involved? That remains uncertain. The lesson we can take from this tragedy is that when embarking on new frontiers, we must prioritize safety, thorough understanding, and improved methodologies. The exploration of our deep oceans and the depths of our Earth will require more resources, knowledge, and careful planning. With that said, thanks for watching, and until next time.
You know, I can't believe that anyone would have gotten into that tube if they would have known that that front viewing port was only certified for 1,300 meters when they knew they were going to be diving down to 4,000 plus meters. So for this attorney,
Adobe just pinged me.
for this attorney to say that they don't have a case with families that lost loved ones, I think he's wrong. Problem is, there'll be nothing left of Oceangate. It's done. Put a fork in it. Please take the time to watch this clip and let me know what you think. You sure as hell know what I think, don't you?